One of the first things we need to get started with is mass balance equations, right? So it comes from conservation of mass. So, things neither created nor destroyed, right? And another part is energy balance, which based on conservation of energy. But let's actually talk about the Adsorbed phase species balance, right? So this left-hand side stands for the rate of change in the Adsorbed phase concentration of species I in end CSTR, right? It is a function Ri of state variables in that CSTR. So basically, we're saying that the rate at which this Adsorbed phase concentration changes is a direct function of the state in that CSTR. Typically speaking, we have the dependence of this rate expression on the states expressed as a linear driving force as shown here. And Glukov is basically has pioneered these types of lumped kinetic model. So you have some linear driving force coefficient, right? Unit per second, and then you have the Adsorbed phase concentration of species I in equilibrium with the gas phase concentration C, and as well as the temperature in that CSTR. So this is so-called isotherm function. So this isotherm function is another type of model that we need to choose based on different types of physics involved in our adsorptive separation system. And this Q and I is the current gas phase concentration of the I species in the end CSTR. It's pretty interesting to note because this Q and I is actually known in our simulation because it's one of our state variables. But the point here is that ideally, in equilibrium, we should be in these types of gas phase concentration. But actually, right now, we're at this amount of Adsorbed phase concentration. So the difference between these two Adsorbed phase concentration provides some sort of driving force, and this K is just rate constant, which basically allows us to match the unit for this rate. So this is kind of pretty simple, really simplified view of this transport phenomena that's happening within this complex geometry of this palette, right? However, in practice, because we are interested in the performance of the adsorption column, not individual, adsorption phenomena going on in each palette, this approach works pretty well. This kind of lump parameter approach, it's a pretty much standard bread and butter model for kinetic expressions. So we adopt this linear driving force equation in our model in toPSAil.